Okay, so I'm going to continue talking about properties of logarithm. So our first property was logarithm with any base with input 1 will always equal to 0. Property 2 was logarithm with the base being same as input will always give us 1. I think we talked about this two already. So number 3. Okay, and then we also talk about this. So if you have a base A, and then if there is a number inside, and if the number B can be expressed as an exponent with the same base as the base of the logarithm, then we said that log a to the x will be equal to x. Okay, so as an example, said, okay, if I take this, let's say 2, and let's say this is 1/8, and I can write this as, so I want to write 1/8 as an exponent, which I can do it as 2 to the negative 3. 2 to the negative 3 is 1/8, so therefore the answer will just be 8 based on property 3. Our next property is this, number 4. So an exponent with the base a, and the power of this exponent is a logarithm with the base a, x, and this will just be x, because the base and the base of logarithms are the same in this case, so then you will always get x. So as an example, let's say you have 5 log base 5, 2, and since these two are the same, then you will just get 2. Okay, property 5. So sometimes, say this is x, this is y, and sometimes we have to write both base and input as an exponent. So suppose x equals a to the m, and y equals a to the n. So therefore, this will look like this now. So log a to the m, a to the n. Now these two numbers are the same. If these two numbers are the same, then you're just going to divide the exponent. So you're just going to do n over n, basically. Okay, I'll give you an example of this one as well. So here is an example. Let's say you have a log 8. This is base 8, and this one is 32. So I can write 8 as 2 to the power 3. So the power is 3 here. And then I can write 32 as 2 to the 5, so that's 5 right here. Now, since the 2's are the same, both numbers have the same base, so then I'll just divide the power. So this will be 5/3. So that's that. And then let me give you a few other examples. So let's say I have a log base 3 1/64. So I'm just going to write 1/64 as an exponent, and let's say well, I'm just going to make this 4. It doesn't work here, so let's make this 4. So 4, I'm going to write 64 as 4 to a power, right? So 64 is 4 to 3, and this would also be 4 to the negative 3, because you can just do the reciprocal to move it to the top. So based on property 3, then we'll just have negative 3 as an answer. Okay. So that's that. And then, okay, so we have this. Now I want to introduce, so before I get to the graph, I'll do the graph on a separate video. So I want to talk about common logarithm now. So common logarithm. So this is a logarithm with the base 10. So common logarithm is basically the logarithm with the base 10. So that will be written like this: log base 10x is written as log x. Most of the And we don't specify the base if we're using the common logarithm. We'll just write it like this. Then it's understood that the base has to be 10. For instance, as an example, just say log. What is log of 10? Well, the base is not there, so then we know it's common logarithm, so it's 10. So then this is really just the same as log base 10, 10. And if the base and input are the same number, you'll just get 1 as an answer. Another example, log, let's say 100. This will be log, I will just write 100 as 10 to the power 2. And I know that the base is 10, so these two are the same, so then the answer will be 2. Okay. So that's the common logarithm. And then there's also a natural logarithm. Natural logarithm, natural log. And the natural log, so we were talking about this. So if I have log a x, now if I substitute this number here with the e, okay, so if a equals e is an Euler number. This number here is already default in your calculator. So this is a Euler number. It's really important in calculus, Euler number, which is approximately 2.71. So if I just use this specific base, then we'll have this, right? We'll have log e, which now we simply just write for this, we simply write ln. Okay, whenever the base is e, we don't write log ex, we just write ln of x. So, and the properties of natural logarithm is just going to be same as the logarithm. So in calculator you will just use this key. So in calculator there is this key for ln function. So we'll just use that key if you are dealing with ln, with the natural log function. So the properties are basically same. So what I'm basically saying is if I change the base of logarithm to e, then I'm really working with the ln function, ln of x. So the base of log, then common logarithm, the base of natural base is 10, and the base of ln is e. So we'll just kind of work with those, and then the properties are basically gonna same, but I'm just gonna remind you the properties. So the first property was the ln of ln if the input is 1, right? So input is 1, I mean, we know this is e, but input is 1, we'll always get 0, right? And the same thing with the logarithm. So the properties are the same, but I just want to quickly go over it. So let's say ln of e. Well, the base is e, so then if these two are the same number, you will just get 1, right? That's what we said. Property 3, ln e to the, let's say, some number. And we know the base is e, so we don't write it, but we know it is e. So when these two numbers are the same, then you just get x. And then number 4 is if you have e to the ln of x, so the base is e, when these two are the same, then you'll just get x again. So you see the properties are the same. So let me just give you guys a couple of examples. Let's say ln of e to the 8. Ln of e to the 8, and we know base is e. So when the base is e, then this will just be 8, right? If the base of the number and the base of the logarithm is the same, you always get the power, right? Okay, another example. Let's say ln of 1 over e to the 3. I can write the reciprocal of this, right? 1 over e cubed, the reciprocal is e to the negative 3. So since this is also e, then you'll get negative 3 as an answer. And there are things that you cannot do it by hand, right? So then you have to use a calculator for those. Like for instance, ln of 5. This I have to use calculator. So just use this key, use ln key in your calculator. This press ln function, ln key, press this first, and then put your number 5, and then press enter. Then you will see a number, which is this. Approximately, of course, it's 1.609. Okay. So and then for the graphing portion of this. So I'm going to talk about graphing on a separate video, like how to graph logarithmic and ln function, how to find the domain and so on. So I'll talk about that in a separate video.